All right, I'm going to do a part 2 because it sort of cut off. I think I hit it with my hand, but that's okay. I'm doing it a little differently this time, but either way, this is 8.1b, I guess, or part 2, whatever. All right, so we said leg is the geometric mean of the part closest to it multiplied by the, multiplied, it's supposed to be parentheses, multiplied by the whole thing. So that would be 10. And so in this case, that's 2 times 3, and that's going to be 2 times 5. So we can pull out a 2. So 2 radical 15. All right. Okay. Perfect. So let's do the next one. It's going to be very similar in a way. All right. The first thing I'm going to do is I'm going to look at, see what we can do. I think we can find x, because if we realize that this, right, is going to be the geometric mean. So 10 is going to be the geometric mean of the two pieces. So the geometric mean of the two pieces, and that's just going to be 20x, but I'll just write x times 20. All right, so then we get, if we square both sides, we get 100 equals 20x, because that would cancel once we squared both sides. And then we just divide by 20 to get x equals 5. So x is 5. And then we can use that, either Pythagorean theorem to find z and Pythagorean theorem to find y, or I can do the geometric mean. Again, we might as well practice that, so I'll do that. We'll say, all right, so we'll say z is a leg, and so it's going to be equal to the geometric mean of the piece closest to it, 5, and the whole hypotenuse, 25. Again, 25 again is a perfect square. We can pull that out. So 5 root 5 is going to be z. We can do kind of the same thing except for y. So y is going to be the geometric mean of the piece closest to it, 20, and the whole hypotenuse, 25. All right, so we have to simplify this a little more. We can still pull out the 5 from the 25, but radical 20 is 4 times 5. So that's pulling out a 2 and keeping a 5. So y equals 10 radical 5. Maybe hard to see, but hopefully we're good. All right, and then finally, if we do the same type of thing, let's see. We can't directly find the geometric mean here. So what we'd have to do is look at the two sides that we have are the leg and part of the hypotenuse. That's what we're going to have to do. We're going to have to say, okay, well, 6 radical 13 is the geometric mean between 18, which is the piece closest to it, and the whole hypotenuse, which is z plus 18. So we get 18z. This is where I need the calculator. I guess 324. Just want to be certain. And then we can do 36 times 13 on this side. Because I squared it, right? I'm squaring both sides. That's what's, I didn't do that yet, but I'm about to. 36 times 13, I did that wrong. All right, so this is when I square both sides, right? So I'm going to square both sides, and I forgot to square that one. But so this is going to be 468 equals 18z plus 3, 24. And we get 18z equals 144. So z is just going to be 8. It's 8. I lied the whole time. It's 8. So this z is 8. All right. And so we're going to have to get some more space here. But so now we can plug it back in, right? So that we can find y, and we know y is the geometric mean of the piece closest to it, 8, and the whole thing, 26, right? I just added those two up. And now that's 2 times 2 times 2, and 26 is 2 times 13. So we can pull out 2 2's, right? That's 16. In other words, we can pull out a 4. So 4 root 13 is going to be our y. The setup's the tough part, and then it's just the follow through with the radicals. And then finally, we can find x. X is just going to be x is the altitude. So it's the geometric mean of the two pieces, which is 8 and 18. Right? Yep. So 8 is 2 times 2 times 2, and 18 is 2 times 9. Actually, this is going to be a perfect square, I think, because 9 is a 3. We pull out, we have a pair, we have a pair, we have a pair. So 3 times 2 times 2, 12. And what was this? I forget. 4 radical 13. Awesome. Okay. Yeah. All right. All right. So a couple more similarity statements here. We'll mark them. So triangle. Let's do MPN. So that's 2 right angle. 1 is similar to the medium one, which we did 2, which is P. Right angle Q, 1, N. And again, you notice how it doesn't really matter how I'm starting. I just have to match them up. So PQN, then we do triangle. What was I did? Sorry, MPN was 2, right angle 1. So the small one would be 2 is M, right angle is Q, and then P is the small one. Okay, and then this one, I'll mark these. That is congruent to this one. Those are congruent there. Right angles, of course, would be congruent. Okay, so let's say RSU. So that's 2, right 1, similar to 2, which is S, right, which is T, 1, which is U. And then small 1, 2, right 1. All right, geometric mean of 5 and 45. Well, that's just going to be radical 5 times 45. So that was going to be 3 times, 9 times 5. Actually, that's going to be perfect square, huh? I meant 5 there, not 9. So we can pull out a 5, we can pull out a 3, so just 15. I guess that's going to be 225, I would assume. There we go. Radical x equals radical 3 times 15. That's to find the geometric mean between those. So that's going to be 3 times 5. So 3 times 3 times 5. Pull out a 3. 3 root 5. 3 root 5. All right. And then we get x equals radical 5 times 8. So looks like we're just going to get, well, that's just going to be 2 times 2, so we can pull out a 2, and then we have 10, 2 radical 10. Okay, good. Finally, we're going to find some more x, y, and z's. Again, y we could find with Pythagorean theorem, or I could find it by saying, you know what, let's do this one with Pythagorean theorem just because we can. We already learned that. Well, learning about it is coming up. Let's do it with what we learned about in this section only. Okay, so we could say y, no, we can't start with y. Let's do 12, right? This leg is going to be the geometric mean of the piece closest to it, 4, and the entire hypotenuse, x plus 4. So then we have 4x plus 16. We can square both sides, so we get 144, right? And then all we have to do is solve from here, right? 144 minus 16. Oops, did that wrong. You can't see that. And then divide that by 4. So 32. X equals 32. And now we can use this in the rest of them, right? We can say, well, y is going to be the geometric mean of 4 and 32. And z is going to be the geometric mean of 32 and the whole thing 36. Okay, and so 4 is just 2, and then 32 is 16 times 2, so that's going to be another 4, and then there are 2 left in the radical. So we get y equals 8 radical 2. And then z is going to be, well, 36, we can pull out a 6. 32, we already said, was 4 radical 2. Right, 16 times 2, yep. And so we get 24 radical 2. Oop, that's z. All right, and then we can do this one. We can start with, we can start with x. X is the altitude, so it's going to be the geometric mean of these two pieces, 30 and 40. Let's see, we can get 3 times 10, 4 times 10, and so we can pull out a 2, we can pull out a 10, and we're left with just a 3. So 20 radical 3. Okay. And then we could do y. Well, y is going to be the geometric mean of 30, the piece closest to it, and the whole thing, 70. And then z is going to be the geometric mean of the piece closest to it 40, and the whole thing 70. And again, this is going to be 3 times 10, and this is going to be 7 times 10, so we can pull out a 10. So 10 radical 21. Okay, we can pull out it's 4 times 10 and 7 times 10. We can pull out a 2 from the 4 and a 10 from the two 10s. Radical 7, so 20 radical 7 is Z. All right. And finally, last couple here. The geometric mean of two numbers is 8. So in this case, we're saying, right, 8 is the geometric mean of two numbers. One of the numbers is 2, so the other number, right, as I said, so 2 and x, I'm going to say. So the geometric mean of 2 and x is 8. So we get 64 equals, I just squared both sides, by the way. So x equals 32. Again, if you just want to backtrack in there and try to solve that, obviously 2 times 32 is 64. Radical that is 8, so that does work out. Okay, the geometric mean of two numbers is 2 radical 5, and one of the numbers is 6. So same type of thing. I'll call them, one number is 6, the other I'll call x. So 6 times x. I can square both sides. Make sure to square both of these, right? Distribute it essentially. So it's going to be 4 times 5. So 20 over here equals 6x, and then we divide by 6 is what I meant. And then, of course, we could leave it as a decimal again or a fraction, but either we get, because it's going to be thirds, we should just do 10 thirds. So x just equals 10 thirds. All right, now we got some problems in here. If AD is 12, CD is 8, find BD. Well, we know that it's going to be the geometric mean of those two numbers, 8 and 12. And we already know that that's 2 times 2 times 2 times 2 times 2 times 3, right? That's 8 and that's 12. Okay, and then we can pull out, looks like we have a 6 left inside and a 4 outside. So there we go. That's this one. I'll do the next one over here, 37. So you can probably look at these. All right, so we get AC, the whole hypotenuse is 16, and CD is 5. So we want to find BC. Okay, so we know that this is going to be, right, what I marked as x. The leg is going to be the geometric mean of the piece closest to it, 5, and the whole hypotenuse 16. It's going to be 4 radical 5. It's going to be this one. All right, and then AD is, and CD are both radical 2. Okay, so it's going to be, and we want to find BD, so x is BD. It's going to be the geometric mean of radical 2 times radical 2, which is radical 2 squared, which is just 2. So x equals radical 2. All right. Okay, and then the last one, BC, sorry, that is there. BC is radical 5, BC radical 5. AC, which is the whole hypotenuse, is radical 10. Find CD. Okay, that's the whole thing. So that way we can say, well, x is the geometric mean. No, we can't do that. We know 5, or radical 5, is the geometric mean of x and radical 10. Right? Yeah. Okay, so if we square both sides, we get 5 equals x radical 10. So we want to divide both sides by radical 10. So it's going to take some more room. So we say x equals 5 over radical 10. Can't leave it like that. So radical 10 over radical 10 is a way to do that. It's a way to rationalize that. And so 5 over 10 is just 1/2. So this radical 10 over 2. Bam. All right, cool. That's part 2. See you for the next one.